Yo. Yo. Chat. It's done. Mission accomplished. It's right there. It's sitting on the desk. It's right over there. It's done. Look, this is a live video. This is a live video. done. We did it. It's done. It works. It cools the graphics card. I'm so pleased. It's installed. There it is. It's beautiful. What a damn process. What a damn process. Oh yeah. It's done. And I have more baby photos. I have more baby photos of the build. All right, so I think we should get into those. Now I'll give it a sec. I'll wait till people pull up. If I'm actually waiting for tech. If tech pulls up, I'll show them the damn photos. Maybe I'll run it back after. But I gotta hit the stream start off song. Yes, yes, yes. All right. So tonight, outside of celebrating, we're gonna tune the firmware. Wait, let me clear this. We're gonna tune the firmware for the temperature control, and then we're gonna kind of walk through the whole thing, and I'm gonna try to record like a video deal, so I don't have to edit a YouTube video, so I can just try in one take to summarize the project. Mellow fire, bro. Thank you. Yeah, definitely something that I have to build in a hurry, which I don't like to do, and I'm pleased to be done. And it works, which almost never happens. So it's good to be on the other side. Thank you. I popped into your stream the other day, bro. Looking good, man, with the damn home assistant. I love that. I gotta get some of that going around here. Automate more of my life. All right, so this is really cool what I've got going on tonight. So I have this terminal right here is okay. Wait, let me pull the paint up. So that you see there's a suspicious wire in this shot in the background. This wire right here. This wire is suspicious. I wonder where this wire is going. That is desktop. That's this Pi is connected to the wire, the USB cable, which is connected to the Pico. So where are we at? So we can kind of live code this thing. Yeah, of course, bro. It was a great little pop in. So make sure you can see this. All right. So we can do. Oh, he's live now. The man is live now as well. Let's go, bro. Alright, so because we're connected to the Pi over the network and connected to the cooler over the network, we can program this thing while it's running. So I can do. Ooh, I kind of have to have the code open. Alright, this is going to be ergonomically weird. Alright. Yeah, totally. I'll hit you up for Home Assistant stuff. Absolutely. I want to work way more music stuff into my setup. Ugh, I can't see the light. All right, so we can read off this thing and work with this thing live. So the MicroPython terminal is connected to the running firmware on the cooler. Let me zoom in over here as well. So we can do all kinds of stuff, but we just got to make sure that those fans stay on, because this thing gets hot. I'm actually gonna pull up another terminal window. Oh wait, I don't know if it's not started. So we can get the temperature off of. Let me swap views. We can get the temperature off of. Paint overlay is being loud now that I moved. Yep. Stream playlist is being the same playlist every time. That's okay though, we like this song. Alright, so that basically means that we can mess with this thing while it's running, which is crazy mode for embedded development. That is so cool to me. So alright, so I have to read my own code, which is always fun. This doesn't need to be as big now. So I can do, what is this called? From Tesla Cooler. So this REPL is live on the cool. This is so cool to me. So we have this resistance to temperature dictionary, which is under my face. Alright. Actually, I'm gonna put this over here. So, we can take like live temperature readings off of the cooler, which is so sick, which is so cool to me. So I can do thermistor pin, so I think it's 11, so yeah, thermistor to temperature, and then it's pin 11, and then we have the resistance to temperature. Ooh, module has, oh, thermistor, not 2, it's just thermistor temperature. Go back and edit it. Does it do line wraps? Probably not. It is on an embedded thing. Alright, so it's just thermistor temperature. Invalid channel? Huh? Module? Okay. Maybe it's not pin 11. Let's pop over to the damn schematic. You know what I'm saying? Oh, that's my bad. It's pin 27, bro. Yep, 55 degrees C. 54. Look, since this is hooked up, we can I don't know why this is so cool to me. We can just like live pull the temp off of the cooler because it's. Ugh, I don't know. I love this. So this is gonna make it very easy to tweak. You know, the fan curves, which is what I'm doing now. All right. So I think what I'm gonna do. All right. So I'm gonna exit out of that, and I'm gonna edit this. Right. This is what we want. The REPL uploader thing. Upload.text. Wait, first. Ooh, you know what? This could have been confusing because I changed my network topology up a little bit. I changed it up. This is now devpi.local. So let's just make sure this upload still works. Yes. All right. Let's knock the music down a bit. The room is so full of fans, it's hard to get the audio just right. Alright, whatever. So we can take this thing. Okay. Might be getting the stream set up. We can take this thing and we can just keep uploading the firmware. So the first thing I'm gonna do, oh, it's already like this. I'm gonna upload a version that has print statements enabled. So it's gonna be constantly printing out it should be. Let's see if it works. So it should be printing off its current status, and it's not. Okay. What is going on? Deployment, upload. This is print activity is true. Not even getting timers configured. Oh. Deployment configuration automatic upload. Okay, that's right. Okay. Huh. Wonder why I'm not getting those print statements. Oh, I think I know what it might be. I think I might need to do this. I think I might need to disable this in the main loop and then do it here. So REPL, and it'd be from main import main and then main like this. Do I have to do, I don't remember enough how that works. I don't know if I have to do the unrecognized command from main. Yep, I think I can do that. Maybe? I should be getting a timers configured message that I'm not getting. Okay. What is... I gotta pull up the research tab already. That's okay. So it's R shell MicroPython GitHub. Dude, R shell is such a beautiful freaking piece of software. Shout out to this man. Dave Highlands, dude. A god. Unbelievable. And everyone else that contributed. But yeah, 14 people. He's on here twice, bro. He's on here twice. A beautiful Canadian man. Alright, so... what was this thing? Yes. R shell REPL. If the command is specified, then... alright, so that looks right. That looks right. What gives? What gives? Be very until the end until it would be. Okay. So, oh, you can't do it first line. That's dumb. So I'm just hitting the enter key with that. Okay. So this will work. Or maybe I need to do another enter. I think I need to do another enter. Yep. So I need to do this thing. Alright. Now it should work. Try number 5. What's good, chat? What's good? Anyone working on anything fun? What's going on? I got some... it's good vibes in here, dude. Assembly went great. I'm going to show off some pictures in a bit. Timer's configured. Yes. Okay, there it goes. Wait, I want the rest of the REPL. What? I want to be dropped back in. Okay. We should be getting print statements now. Nice. There we go, baby. Wow, 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 wow. Okay, so this is verifying what I thought was happening. So look at the difference between the temperatures of those two coolers. So one of them is 36 and one of them is 54, 58, 55, 35. Okay. Straight up not chill. Okay. Stuff this. They're different fans. They ended up being different fans that I got when trying to buy the same fan from Amazon, but it ended up working out fine. A little louder than the initial ones, but it's okay. I'm fine with that in terms of getting this project done. So let me full screen this. So just for some context, so I did. Oh God. Oh God. Okay, so no. Okay, it's easier to see over here. So this guy. Okay, too much. Okay, it's actually easier if I do this. Windowed, full screen projector, bang. Oh, nope, wrong one. Window projector source. Window projector, full screen projector. Alright, this will be easier to see. So, nope. Yep. Okay, so So do A is this guy, and B is, oh no 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 no, that's wrong. Is it? The hotter one, 56. Yes, B is the hotter one. Okay. So this is cooler B. And this is cooler A. Dude, this frickin' stylus is so useless sometimes. Where is it even going, dude? Okay. It doesn't want me to have good penmanship. That's fine. Alright, A and B. So, A has a ton of airflow. Or B. Did I do it wrong? Son of a bitch, I did it wrong. Okay. Cooler A is the cooler one. A, B, it wants to do dots and not lines. Why can't I not do See, it wants to do, it's like rejecting the input. Whatever. I think that's good enough. You understand what's going on. So A, the cooler one, has all this big, beautiful space on the outside to let air dissipate. And cooler B has another graphics card in front of it. So that's why it's hotter. All right, 30 minutes in. Let's get it popping, baby. All right, so what we want to do is make Cooler B's fans spin faster. I think we can do that with this file. Or maybe we can do that with the fan curve. GPU cooler. Yeah. So, see how this is? Wow, it's like chilling at this low temp. Okay. Problem is this. I want the temperature ranges to be to not care about what fans are plugged into it. Yeah, I have to do this with the fan constants. Yeah. Alright, so what is... Wow. Wow, so this really wants to be slower. This wants to be much slower than it is. Because this is sticking at like the lowest thing across the 3 fans. That's interesting that it's... So I'm gonna also log target power. That's the first thing I'm gonna do. So we're gonna go like this. Speeds. So we gotta make this a tuple, a fully defined tuple that is an int to another tuple. Should be a name tuple, but I'm learning to not care about the details. I'm trying to not care about that much. Alright, so yes. Stream intro song, running it back midway through the stream. So target counts. So we can do this, change that type as well. And then yeah. All right. So now we can do this. Target counts, and then we can do. Is that what it was called? Target counts. And now we can just freaking upload it right to the ting, man. Alright. Alright, so target count 1600. Yeah. Huh. I'm just gonna be printing. No, I'm gonna print both. So it's going for 1600. It's getting 555. What was the slowest thing can spin? I did this on stream and it was like, it was 5,000. The problem is this the short wire fan doesn't really spin slower the less voltage you give it. Like the range is almost nothing in terms of like its RPM range. I can actually delete this. Alright, so I think this was like a hard number. So maybe what I should do is I should do here. Fan drive. Okay, so fan drive values already has fan contents. Maybe I should make that rounding error thing, the tolerance. Maybe I should make this the min output. Ah! Ah! Fans are not running. Fans are not running. Ah! Okay, I'm not gonna fuck with that. Not gonna fuck with that. I'm sorry, I'm sorry, I'm sorry. Ah! Okay, not gonna fuck with that. Okay, what I might do, I'd like yeah, I'd like the faster fan to make less noise, and I would like the quieter fan to make I'm just gonna add another couple of ranges here. 2 to 3, 3 to 4, and then I'm gonna delete this range. So the slowest I could spin is 3,500 ticks. Let's try that one. Okay. Okay. Add another step to this as well. 50 to 70. So I'll make this so now they should be a little bit more aggressive. Know what I'm saying? Okay, so maybe I need to like, that didn't really help. I'm gonna do this. GPU temperature equals current temperature oh come on, that's annoying. Plus 20. So that might actually do what we want. Unexpected argument. Key GPU temperature. Ah! The refactor button has blasted me. Cooler fan power. Too many values to unpack. Cooler fan manager, 96. Bet. Okay. Oh, this is what's happening. Okay, so that's showing me that the other fan wants to max out on speed now, which is good. Yeah, there we fucking go. Yes, I'm gonna go feel this. Okay, loud as hell, but we're gonna watch it cool off now. Alright, I have to... I would love to get the actual core temp of the GPUs, but I think they crashed. I think they crashed everything. Air start command failed. Yeah. They got too hot and they crashed. And the problem is so I'm gonna move this. I'm gonna move this out to the top. actually gonna change this as well. Just get rid of this whole else. Alright, so that's just mad loud. We're cooling down though. Alright, so this is what we want to change to. Yep, yep, yep. Alright, so having the so alright, so no. So this is the thermistor temperature. So this is so it's more like that. So the difference between the temperature of the outside thermistor and the actual internal thing that matters is like literally 20 degrees C. What happened to the aggression? So now those are way cooler. Alright, so annoyingly, I have to turn off my development environment for a sec while I reboot that computer. So I'm gonna open a screen. Ooh. On the development Pi. I'm gonna let this rock for a sec, and I'm gonna commit and reboot. Huh? Marshall P. So now I should be able to reboot the whole thing and yep. That 33.75 number, didn't I? So I think I'm going to put the half power mark at 60 degrees. Because that's kind of loud. Yeah, this thing might have to live upstairs. Shit. Alright, whatever. Progress. I think it should be 30 to 60, maybe third power. And then we do maybe 2/3 power here. So let's see what if B dips below 60, what happens. Why is it staying the same number? That's why. Ah, this function sucks. You can feel the fans again. Okay, so I'm gonna reboot. So music's gonna go down too, unfortunately. How is music still working? A little more changes to the cat. I did make this file though. That is the 3 generations of this thing. Which is tight. I have a bunch of photos too. I was gonna get into that later. Later. Chat, what's going on, bro? While we wait for this reboot. You guys working on anything cool? Maybe. Oh, I hear the reboot going on. Alright, I gotta BRB. I gotta check on something. Okay, Jesus. I think I'm back. Alright. Woof. Nothing like having to do a quick reboot during the stream. Love it, love it, love it. Alright, so where are we at? Where are we at? Where are we at? So we wanna go. Thought you were at the airport for a minute. What's up, bro? Tech, what's going on? What do you mean at the airport? This is a tech joke. Joke incoming. Everyone be... Oh, because of the fans. The fans are loud as hell. Damn, are they? Is it coming over crazy? This is the problem, dude. But, yep, the fans. Is it that nuts? Yeah. This is the issue that it's not that bad. It's not bad. Okay. I haven't actually listened to the stream in a sec. Let me do that. Ooh, it's bad. What if I... What's it sound like in person? Loud, bro. This is the problem. Let me turn my mic down. Check, check. Alright, we're just gonna live with it. I actually have... Whatever. Not gonna worry about it. So I have a mic. So that is... That's the same, okay. That's the same gain that my voice mic is, and it's on the fans. So as loud as I'm talking, that's how loud the fans are. But I got pictures. You're here. I was waiting for you to show up. So I got pictures of the whole thing. I want to show it off. All right. But first, I want to finish my thought. The card that is wow, okay, so the card that is on check. The card that is on the outside, let me draw. Nope. Bigger pen. This one is significant than the other one because there's no like air gap in between. So that's kind of a wrinkle that I wasn't necessarily expecting. Or like I was expecting there to be like a difference, but it's like it's literally twice as hot without that extra ventilation. I don't understand how these people, like, what was the plan for cooling these things? I just don't get it. So I'm tweaking the firmware to try to get around that, to like change the steepness of the fan curves per card. So that's what I'm working through now. Tech, what's going on though, bro? How you feeling? What's going on? Fill me up. Keep me up to date. How are the dogs? How's the fam? What's going on in Arkansas, my brother? How are you? Alright. Things are just meh at the moment. Why is that? Work week got you down? Beavers damming your river again? Not good, not bad. Alright, hey, we'll take it. You know what I'm saying? Alright, so I have to expose a way to do that offset change. Actually, you know what? No, I have to do it because then it'll be quieter in here. I have to do it. Alright. Alright, so switch up the damn tune. Oh, that's not working. Weird, weird, weird. Alright, alrighty. So I have to expose a way to change. Oh, I just closed it. Damn. I have to expose a way to change kind of the multiplier per fan, which is not that big of a deal. So what we're gonna do is, so we're seeing cooler A, which is the cold one, is 55, but then in reality it's more like 40. So that offset isn't 20, it's like 15. So minus 39. Oh, music fucking up already. That's the playlist. The playlist is cursed. Alright, no tunes. No big deal. Alright, so the offset, oh man, the tunes kind of cover up the craziness of the sound. I am rethinking no tunes. Artists, £1. Bang. Alright. That's actually pretty close. 58 versus 56. Why does it just change temp so much? Oh, no. Okay, so this is 67 versus 58. Alright, so it's more like... Wait, so... GPU temperature is actually cooler. Alright, so I'm gonna do... Hopefully a lot less fat by the end of the year. Bro, me too, I'm on my salad shit like crazy. I'm young, healthy dude right now. Yeah, I feel that. After the summer, dude, after the end of every summer, I'm always like, man, I had too many beers. I was hanging out too much. I was going crazy. I don't know, but, well, you know, definitions. Yeah. I mean, it's good. That's good goals to have. That's how you know you're in a good spot. If your goal is your health, instead of just like, yeah, I don't know. It's good. It's definitely the way to be. Have you like made any cool changes? Anything working? Anything not working? I'm actually interested. So I'm gonna pass this into the log as a tuple. So the thermistor, we could hit too because of it. Cards are completely. Damn. The cold turkey shit never has worked for me. I admire it, but I end up just like snapping back super hard. I admire your technique though. I'm not powerful enough. Alright, so we set up the thermistor to collect data from the thermistor. Well, we kind of have a, I would say the GPU is the thermistor. So this is the console for the graphics card. So we're trying to get the mapping between those two. Because the thermistor inside of, or like whatever the temperature sensor inside of the GPU is, it's always gonna say it's hotter than the outside of it, like where our thermistor is. So you kind of have to just like make sure that mapping is more accurate. So I guess we have thermisses, which I like. Alright, so it's, if it's 66 but it's actually 58, it's like a 10-degree difference. And I guess the outside is hotter, which is not making a ton of sense. Yeah, the outside is significantly hotter in both cases. So this offset is in the wrong direction. This is, yeah. I'm starting to think that might have been the move as well. Yeah, no worries, man. We just do plus temperature offset. Just kind of boosted. What was that? Oh, okay. Alright, so this is printing the plus 20 number. So if I do... Yeah, so okay, so if I do... Thermistor calc. So if I do this, thermistor temperature, current GPU temperature as a tuple, then I'll get the best guess. Alright, so if I do that, and then I do just offset set to 0, I'll do the same thing over here. I could turn that camera off, and I'll keep it up. I'll keep it up. It looks cool. Alright, so... Whoa. Okay, so this is the actual temperature that the thermistor is reporting. So for the Are they moving? They are, just very slowly. So, hot side is 38, cold side is 58, and then over here, 36, 46. So GPU temperature is pretty accurate on the cold side. 36 versus 38. Okay, so now it's heating up. Let's do plus 5. But on the hot side, it's like 15. Man, I need to get some sleep. I'm tired after tonight. All right, bro, wait, let me quick show you baby photos. Very quickly here. Just because you've been here for a minute. All right, so we got, I'm pulling up the pics. Projects, boom, Cooler CAD, photos. We need to come up with another project. I got ideas. I'll tweet ideas and see what you're interested in. We got photos, bro. Ooh. Ooh. All assembled and crispy. Yes. Yes. The thermistors. This is the first version. This was the first version on the desk many months ago. This is V2, which never actually went inside a case. It was the same configuration where it was just hanging out like a motherboard like this. Same controller though, same fan, same controller. And then here's V3, which I've shown a couple times. Where's that other picture? But that's it, bro. It's been it's a clear improvement. It's a lot louder though. Yeah, here's the other one of V2. Just disgusting. Just one of the worst designs. But now we get something that I'm really proud of, which is great. All right, tech, yo, have a good one, thug. Louder, but it works so damn well. Exactly. I will tweet. I'll hit you on Twitter about other ideas. I got like a lighting idea I've been thinking about doing. Work is getting nuts. My day job is getting nuts. So I might have to stop streaming for a bit, but when I come back, I'll probably have a couple in the chamber. But I'll tweet at you. Yos, thanks for stopping by, man. Cheers. Have a tea if you're in the tea mood, but you're going to bed. Don't have a tea. Peace, bro. All right, let's get back to trying to code the same thing. All right, so hot side is like 40, 40s, 50s. Yeah. It's like 10 degrees and 20 degrees. So the GPU temperature is on B, who is the hot side, it's plus 20. And on A, which is the cold side, it's plus 10. So let's see how that actually translates into the numbers. Know what I'm saying? Whoa, okay. Yeah, 62 versus 69, 63. $47 versus $53. This isn't a linear mapping, I think. Okay, well, this is good. I think this solves the problem. No, it's more like 15. So hot side is 66, cold side is 51. Damn, cold side is like accurate as hell, bro. Is it 0? So it's 50 and 65-ish, or 40 and 65-ish. 64 and 40, 66 and 40. Okay. It's a little bit better. Okay, so let's let this percolate. Oh, that's so much better. Yo, I think the fans were fine. I think I just had the offsets wrong. Let's say 42, 39. That's wrong. It's 3 degrees off. 65, 64. That's about right. 38, 42, 43. So now that's a 5-degree difference. Yep. That's like a 6-degree difference. 67. Okay, I'm gonna do 5 and 15 are gonna be the hot side, cold side offsets. And then I think we're gonna test some shit out. Crank it up. See if we can get some heated up. I think I might put the lid back on as well. So 44, 60. What do we got? We got 45, 63, 65, 44. Okay, this is more accurate. $65 versus 63. Yeah. Alright. Goddamn. I think we got it. Alright, so those fan curves. I'm gonna make this one's 70 again. Get this spinning lower, like under that first notch. This could be a lot better. Yeah, that's what I say there, but whatever. This works for now. Works for now. Okay. Alright, that's pretty accurate. I think I'm gonna delete this first spinning range because it just doesn't sound good. Yeah, it's a little easier to listen to. Okay. Okay. I'm gonna add another field to this. Okay. So just for posterity. So min duty is 3K because we're not using it anymore, but I still want to keep it around. Okay, so where are we at with this? Alright, so we gotta add some docs for this stuff, for those changes. And then I think we're going to, actually, you know what, before I do the docs, I'm gonna do it while they're in my head. So this is a float. Temperature offset. Between the measured temperature, between the temperature thermistor and temperature of the GPU. This was value set in main. Yeah. Since the thermistor on the is attached to the outside of the GPU, it will always have a temperature measured by NVIDIA SMI. Okay. I'm gonna add a to-do is here. To-do. Okay. Find usages. Returned experimentally. The other side of the card faces the motherboard, has plenty of room. Okay, sick. Alright, we're chilling. Camera adjust. Alright, so now I'm gonna commit. Added per GPU temp offsets. You guys want to watch me fix the linters? Too few public methods. What? What? Why is that complaining about this now? All right. Yo, first time chat. What's up? Amanuensis. What's up, what's up, what's up? Yo, okay, let me give you this freaking tour, bro. You got a sec? I can give you the whole tour of the whole project. What's up, what's up, what's up? Alright, so what I am designing is let's get into it. Let's freaking get into it, bro. Welcome to the damn stream. Alright, so there are these graphics cards. Let me do this. Can you still hear me? You should be okay. Okay, cool. So these things are called the NVIDIA Tesla K80. And ooh, whoops. Need pen. Where is pen? Pen. Check. Okay, there we go. Awesome. So these bad boys are graphics cards that are used in like high intensity. Oh, we use a bunch of them at work. What's up? All right, so you know that these things are normally used in like industrial compute applications, and they don't have DNN training. That's exactly what I'm doing with them. That's so funny. So I don't even have to give you that much of an explanation about why, about like the what. So the why is I needed a cooler that would fit in like a server case that would be able to have the cards use like their full power, and be able to fit two of them like side by side. You can kind of see it in the video earlier, but this is like the installed. So like I couldn't have anything that could like wrap around or do anything like that. They had to be able to fit parallel like this and like have some more room back here. So I have been through a couple of iterations of this. This was the first version, which was using these like very crappy 3D printer blower fans that I had lying around because like I had bought for my printer. I had one fail, so like it came in like a pack of 6 or something, so I had like a bunch of these lying around. And obviously you probably know that this didn't work. Like it worked kind of, like the card was able to do something, but it was not enough air to cool the card off at max power. So then I did a similar design that had like a lot more of a straight shot. This one didn't have to sit inside of a case. It was the same thing as over here as the previous one, where it was just sitting like on the motherboard like this. Third design, which was basically just another version of that second one. This fit inside the case, and this kind of worked, but this definitely did not have enough room to fit the second GPU. So that's where we're at now, and this is kind of the final stream in a series going over the design and programming and manufacturing and assembly of this whole project. That's what I've been doing on stream for the last like 4 or 5 streams. Yeah, so this is the finished thing. It's programmed Raspberry Pi Pico and MicroPython, has temperature sensor on board, the GPU, a thermistor on board, and we're just working on tuning that now. And I'm just going to try loading down the GPUs to see if the super cool. Yeah. Also, super loud, turns out. I'm kind of sad. Another requirement that I don't think I'm going to hit is I want it to be quieter than it is. But, you know, fitting the other cards, yeah, small fans was loud as fuck, right, exactly. Yeah, and it was like, okay, I don't really have the room to do like a 120 millimeter case fan, and I don't know. I thought there was a couple of yeah. The thing is though, if you spin them slow, they're not that bad, so I was like, maybe I can limit, maybe I could like truncate the upper limit so they only spin within the quietness range, but then it was like, okay, that's not enough power, and but all in all, I'm pretty pleased with it. But what we're doing now is we are gonna crank up the load on the cards. I have to do this stuff at work. We put these in industrial settings. I'm very happy. It's not gonna be my problem. Yeah. So what do you guys use to cool them? Because if you look online, like it's all over the place. Like the actual coolers that are meant to be used for these things. There's like tons of people that are doing like the DIY thing, but then actual like photographs of the real deal coolers are kind of few and far between. So what do you know? Have you seen the setup before? Do you know what it looks like? I'm curious. Okay, so let's load these cards down into a DC ambient to pressure keep cool enough into a DC into an AC, like an air conditioner. Is DC it's a data center? Oh, okay. Yeah, see? I can't do data center. Yeah, I can't do that. I'm in my tiny Boston. Yeah. And I'll cool like low 60s. Yeah. I'm in a little apartment, and I can't really keep it cool all the time, dude. That's cheating. I love that. I love that approach though. Just cool to make the whole building a fridge. I love that. That's awesome. Yeah. I'm from there, man. Oh, love it. Let's go. Yeah. Very cool, bro. Awesome. Yeah, love it too. Let me see if I can find a photo of the cooling style we use. Yeah, I'm super interested. It's so awesome that you hopped into the chat, because I've been like looking for, and if it would be so funny if that's how they're expecting these to be used, because that would make a lot of sense. Like if you it's like a huge. I don't know if you've taken one apart, but the heatsink is massive. Like the back pressure, you have to apply so much pressure to these things to move air through them. But yeah. All right, so let me load this thing down. Let me load this down. All right, so this is kind of gonna be weird. All right, so So we got the Docker file. We want that GPU. Okay, so let's do. All right, so. Manuasis. Dude, that's so awesome. He hopped in the stream with the passively cooled data center one. I love that, dude. I wish I could do that. Maybe one day. Alright, so I gotta pop this container open. This is gonna be a sec. This is not gonna make that much sense but just know that what I'm trying to do over in this terminal is increase the load on the GPU. Alright, so alright. So what do we got? Do I have any saved commands that will heat this thing up? Okay. Project video to file. This is what I want. Okay. Alright, so if this starts to run, Nice, that's starting to do something. All right. There it goes. TensorFlow is waking up. All right, so we got 70 degrees over here. What is the thermistor reporting? 67. So it's a little off. Shit. 72. No, bro. All right, so I think it isn't a linear relationship. So we do have to have that constant be higher. This is good. So this will be good to see. Yeah, 65 watts out of 149. All right. So it's like another 10 degrees off. So I'm going to just change that while it's running. So it's 25. All right, so where is this? There it is. Yep, rapidly climbing. Okay, there we go. That's more accurate. $87. Damn. It's even more. It's like 30 degrees off. $35 off. That's crazy. So this is okay. Wow, are the radiators exposed like that? Okay, I see what's going on. Wow, that's great. Damn, I'm envious. Okay, that's taking off now. Let's see if this is gonna go down. 84, yeah it is, boy. Yeah, that's so sick. They get hot, but it's a lot. Now there's a cover on top and needed to increase the airflow. Okay. Yeah. Damn, dude, that's awesome. Yeah, so I don't. They have the cover on. Okay. Yeah. Alright, so we got a load on the GPU now. Ooh, and it is plummeting in temperature. I guess we're also partially competing here with the fact that it does take like an amount of time for the heat to transfer to the thermistor rather than like whatever internally is going on here to move that number around. So So at any given point, it could be pretty far away, but like over time, I'd imagine it's going to be pretty similar. I think I'm going to leave these constants for now. And sounds like a solution for a PID loop. Yeah, I tried. I gave up on the PID stuff. The problem is I need auto ranging because the cooler isn't gonna know when the cooler has no idea what the load conditions are of the GPU, but like there is like a modality, right? If they're just idling, there's like a whole different set of drive parameters I want. So I think in the long term, like I think that's something, if I continue to work to improve the software, that's something I'll do. A PID loop for sure. I tried though, and I ran out of time. Today's the last day I want to be working on this. So yeah, I did try. I ported over a PID library from Python 3 to MicroPython, and didn't go well because there's I don't know. So I tried and failed. Yep. If you really damp too because of the delay, right? Yep. And it's like, okay, if and if I were to want to make improvements, I would love a way to get So it's one of those things this is why open source is great, right? When I publish this, and if someone just comes along and is like, hey, I want PID, and then I can be like, okay, cool, I'll put PID in mine as well. So maybe if you ever get into doing this kind of stuff at home or whatever, if you need to implement a cooler, you could fork my project and work with it that way. Cool. All right, so let's try increasing the TDP of the better bang for your buck, just moving the heat further out with a heat pipe or something, so you can use a larger fan. But then the problem is that you would there isn't really that much real estate inside the case, inside of the chassis, but it's definitely a good idea. I love heat pipes, and it's hard, and it'd be hard for me to manufacture heat pipe stuff at home. I've never worked with that. I just have the printed parts and standard mounting hardware. Have to do some stuff. Yep, exactly. But heat pipe is good. All yeah. Yep. That's a metal fab and weird chemicals and shit. If I were to make this a business, yeah, obviously that'd be something I'd want to do. But this is just a open source project in service of another. Yeah. Artisans. Yeah, Artisans is awesome. They have a PCB mill that I have put in a lot of hours on. They have a Bantam Labs PCB mill. Yeah, done under a vacuum. Yeah. It'd be fun though. That would be its own project though, doing the heat pipe part. All right, so let's increase the TDP of the card. So I can do this. So I can do I0. Alright, so none of the stuff, none of the throttles are active, which is good. So let's do power level 175 watts and see what temps we get. Persistent mode is disabled. I think I have that. No, I don't have that more recently. Damn. Had it in the grep though. Amanuensis, what do you do for work that you're training the neural nets? Oh, awesome. Hey, that's good to hear, dude. I haven't been back in a long time, but there was a period while I was working on a freelance project and I needed that PCB mill, and I used it a ton. I still have a bunch of the, I should probably donate the bits that I've used. All right, power limit increased. Power limit increased. All right, 175 watt cap. Nice. Yeah, I feel like that's why. That's so funny. That's not the first dude I've heard that's moved to San Francisco to build giant robots. I feel like I hear that story all the time. I'm moving to San Francisco to build robots. Awesome. Mm-hmm. Alright, so we're not hitting that upper power limit. 83. I guess probably not seeing the spikes though. There's one other thing I wanted to do. All right. Jesus, I don't want to say that we're done here, but we might be done here. I unlocked the power consumption. We're still at good temps. GG indeed, dude. What do you do for work, bro? Amanuensis. Amanuensis? Training the neural nets. It sounds sick. Alright, so I wanted to... Alright, so let me just commit my freaking changes. Software engineer, I don't look the stuff, that's other people at my gig. Very cool. Yeah, I'm a data ops software engineer too. Yeah. That's very sick, bro. Bostonian software engineers. I guess there are a lot of us. There are a lot of us. Alright, so let's see here. I wanted to I'm gonna put the lid on. So we're at full power consumption, full tilt under the load I'm gonna be doing. I'm putting the lid on to see. We got it live. I'm gonna put the lid on real quick and see if that changes things. so lid's not all the way on. Lid is on enough though to have enough of it. Ooh. Oh, bro. You got some secret. Watch into NVIDIA. Oh, yo. Okay. 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 Bro. N is in seconds. Oh, I love it. Control C to terminate. Dude. I wish I had a soundboard. That little tip is soundboard worthy, bro. Thank you for that. Wait, okay, so you'll appreciate this. So, this is a really cool setup. So, have you heard of MicroPython? So MicroPython is like exactly what it sounds like. So the way I'm programming the controller, the fan controller, so I have a Raspberry Pi hooked up that I'm SSH'd into over Wi-Fi. Via USB, I'm connected to the Raspberry Pi Pico, which is the fan controller. So then MicroPython, let me turn off the debug logging. So MicroPython lets you like drop into a REPL in like a hardware scenario. So this REPL, when it pops up after it uploads the code, so this is running on the Pico in the like on the cooler. So this terminal is like live running on the cooler, and there are these things called but over TTY, but it's not to the Raspberry Pi, it's to the Raspberry Pi Pico, the controller itself. It's like, yeah, it's so cool. And there are these things called timers in MicroPython, which are like basically you can attach a callback function to them, and they just run in the background, and you can like change how often they occur. So like all of the logic for the controller is like currently running in the background of this thing. So if we like take the code to, yeah, Micron's not done a lot with it, but a tiny bit of ESP32. Micron, yeah, so cool. I don't know if you've had experience with other hardware development stuff, but this is like amazing. Normally the kind of the hoops you have to jump through to like, yeah, try to stay as far away as possible. This feels like I'm writing like on an EC2 instance. Like this feels the same. It feels the same as like running on a production server, like, or something like that, or like it like, but it's like hardware. It's like we can like read these registers in real time. Like I can write. I'm doing it right now. So if I do here we go. Oops. So if I do this, whoa. Okay, it does not love this width. So from okay, it's not loving. Tesla Cooler import thermistor. Ah. Huh, I don't know why it is not. It's being weird, I think, because I'm zoomed in. But anyways. Anyways, the developer experience from other like hardware background stuff is so much. It's so much more interactive than normal hardware stuff, which is like such a breath of fresh air in this world. So from, it's like getting the character order wrong. All right, whatever. I'm not gonna see. This is when I start making mistakes. It's TTY lag. Something. Actually, it just looks wrong. Right, that's probably what it is. I have the Pi going over SSH, and there's a lot of ignore what's on your screen, just touch your typing. Okay, I'll believe. From Tesla Cooler import thermistor. From Tesla Cooler import thermistor. It's like getting every other character. Ooh, this is freaky, dude. Alright, I'm gonna plug it in. I'm gonna unplug it and plug it back in. Yeah, I have a. Ethernet to the rescue. Or not? Alright, I'm back. How should that normally come in there? Thanks. Yeah, exactly. Okay. Alright, let's try. Let's try again. Alright, that seemed much faster. Unplug, plug back in. I probably have been really abusing this thing. Alright, so from Tesla Cooler import thermistor. Oh, it's doing it again. Alright, fuck it. Not cooperating. See, this is what happens. I try to transition off of it, and then I just get craziness. Alright, so anyways, it's cool. It's been way different than every other embedded project I've worked on before because of this this difference. All right, so so next what we want to do is reset the uploader script. So compare with branch, origin integration. Okay, so that's all right. Okay. So alright, that was the final upload, methinks. Alright, and then we got the watch command going in the background. Hell yeah. Alright, so 72 is not bad. 72 is right in the pocket for a full load. That'll definitely increase. Yeah, I gotta stand up another container alongside this, I think. Yeah, unfortunately, not bad at all. Let's get it. Henry O. Yo. Henry O is in the building. Henry O's in the building. Play this motherfucker's songs, dude. Yes. Yes. Let's get it. Henry, dude. Henry, you're back. I gotta show off, dude. Alright. Let's get it. What's the one I like a lot? Yes. Alright. Dude, check this out. We got photos of the final. Bang, dude. Bang, dude. 2 in there, no problem. Cool as shit. Temperature wise and aesthetic wise. Woo! Woo! Got the embedded thermistors. A beaut. A true thing. A true beauty. I'm pleased with myself on this one. I never get to be pleased with myself. In terms of engineering projects, it's always like this weird like halfway thing. This one was nothing but net, bro. Yeah, compared to the previous version, which is this horrible giant thing. Yeah. Yeah, bro, it's done. We're done ski. Swish. Yes, brother. Yes. Hell yeah. I'll give you the damn tour. So V1 right here, V2, and then V3. Mucho better. A little bit loud is kind of my only thing I'm not happy about. Ooh, network camera looking very bad. Go ahead and turn that off. Yeah, bro, it's done. Little under 2 weeks, which is annoying. I thought it was gonna be like 1 weekend, but it ended up being like 2 weekends. But we're rocking it now. Has Pounds told you about the project that this is getting used for, or is that still hush hush? Has 1 Pound disclosed the secret project? Alright, so I wanna... Haven't heard anything. Perfect, bro. Alright, so I don't want to do that. I want to do... yeah, maybe not. Alright. Alright, alright. This is related, dude. It's top secret, bro. This is related to a 1 Pound project at its core. And that's all I'm gonna say. Alright, so let's load down. Oh, duh. Alright, so this is gonna make... No such service developed too. So how do I do that with Docker? Ooh, I'm in the wrong screen. Shit. I want to do another second Docker container. Actually, let's just do this. We'll just copy. We'll just make it develop to. Pass in GPU number 1. Alright, so I want to upload this. Upload to GPU development. Block end, but no mapping. Block start. Oh! Alright. Line 9, column 90. Wait, what was it? Line 90, column 3. Huh. What? Is it just that one new line? That would be silly. Let's try this. Oh, I might have copied it on top of... Yep, it's the wrong indentation. Come on, mate. Whatever the hell this is. Develop 2. Return of the develop. Alright. Deployment, upload to. Gonna do it for the evening. Cool catching up with you, man. Good luck on keeping it cool. Thank you, brother. Yo, thanks for that pic. That was so sick. Yo, have a good one, bro. Alright. Yep. Let me just run. What are we gonna do for tunes here? Ooh. This is what I'm gonna do. Alright. Alright, are you ready? Alright, so this is gonna be GPU 1. We're gonna beam this up. Fuck, hit the wrong key. Upload to, no, tools, development, upload to, development, bang. Alright, develop 2, there we go, awesome. Oh, it's not gonna like that it's the same port. Let's just do 223. Deployment, upload to, development. Alright, this is gonna rock out. 73, not freaking bad. We do Yeah, it's still running. Sick. So this will be the worst case scenario. So this is gonna be persistence mode. We gotta enable that shit. This is gonna be both GPUs on a card, full tilt, full power, and to see if we can keep it cool once this boots up. Chat, what's going on, bro? What up? Alright. Let this download. Crazy town. Alright, son. How's my audio over here? Ooh, a little loud on the damn planes, dude. Alright. So now that that's tuned in, the stress test is going to show if we need to change that even more. And then the other thing I wanted to do today was kind of just do like a recording of just an overview of this entire project. Because normally at this point in the project, I would film and edit a video and then put it alongside the blog post. But I'm going to try to do it live. I'm going to try to live cut it. And we're going to see how that goes. Probably going to be weird, just like everything else. But, you know, the live thing has been fun. It's been an interesting way to work on something. I'm amazed at the chat. There's been like 4 or 5 or 6 different occasions where someone has popped in and dropped just like a total gem, which has been awesome to have as a resource. Yeah, a lot of times people have really fucking good ideas, which is awesome. Something I wasn't expecting to see as a benefit to working live like this, but it's been amazing so far. Alright, so just something to be doing while this is crunching along, while this is downloading the images. You know, or I could go get tea. I'm gonna do that. Alright, I'm going on break. I'm back. What's up? It's still downloading, bro. Come on, Docker. Taking forever on my. Alright. Oh no, it's basically done. That's lit. Alright, so. That's lit. Alright. Error? What? The name is by container. You have to move or name the container to use that name. Cannot create container servers for develop to conflict another game container. Cannot container for service develop to name / develop is already in use. Fuck. Where is / develop? Ah. Damn. That's all good. Upload to development. Wait, is that actually? Okay. All right, so I'm actually gonna work on that little live loop thing, because that's worth showing off in the video. Alright, so I guess we can do a function def read thermistor temp one shot. We can just do so all this is going to do is read the configured, read the mapping from disk and consume it to get the current thermistor, the current temperature, of the attached thermistor. Alright, so so this is kind of naive. So we're just gonna do Mr. Temperature, pin number, Mr. Pin number, and then resistance to temperature is just going to be the read resistance to temperature, and we're just going to immediately chuck the mapping. Alright. So we're going to want to do, we're going to want to do and then we're going to want to do for main import main from Tesla Cooler import, oh no, so Tesla Cooler dot thermistor import this bad boy. Alright. Aww. What the hell is it called then? I spelled Tesla wrong. So what was the pin again? Okay, that server's down. I'm taking the lid off because this looks boring. I'm back. Ugh. I know I entered my password wrong. Relax. Alright. It is pin 26. Pin 26. Alright. Timer's configured. Nice. So. Okay, why is this being. Let's like Google for this a little bit. Raspberry Pi Pico scrambled micro input. REPL lag. Accessing MicroPython REPL. Alright, so where is that other thing at? It's done. Nice. So we can do GPU at localhost port. Is this a screen? It's not. Localhost port 2223. Yes. Nice. Alright, so what we gonna do? So we're gonna do exactly what we did before. We're gonna call it second test. Okay. Alright, so we got this second GPU heating up. This one. Alright, so it's starting to allocate memory. Oh shit. Starting to heat up. Wow, wow. It was like up to 1 mad fucking power. Huh? Oh, this is the wrong... What? Connection closed? Okay, so this is away. Ooh. Why is it? Is it because it's not in performance mode? So this is like 59. I'm seeing 59s though over there. I'm trying to see 0.5s here. Is it the performance mode thing? Alright, so that's running. Oh, this fucking rocks, dude. Alright, so... I had a note on this. K80 push. Yep. Silencers and element fan control, yep. Ooh, we're really starting to heat up. 58, 86. Are we throttling? Yeah, because it's sucking up the hot air. Idle active. I don't really want loop. Software thermal. Slowdown not active, that's good. That's good. Yeah, 87 is about as hot as it's getting. I kind of want to see what the thermistor's doing. Let me change this to be a function. So I can do while true, just print this. Nah, nope. Can't do it. Don't want to do that. Can't do it. We're gonna do the logs the way they're meant to be consumed. This thing. Okay. Ooh, it is sounding nuts over there. Oh wait. Stop. Alright. Oh, I gotta unplug it and plug it back in. Brr. Power supply fan is starting to heat up too. Why is this not working? $75C, let's go, dude. Whoa. Oh. Alright, so the thermistor is reading, it's 9343, and in reality it's 8541, which to me is within the margin of error. Notice the power level is under 100%, which is great. So we still have room to go in terms of our ability to cool the fans off. I'm gonna put the lid back on. The lid is back on. Okay, so let's see what the temps do now. Yep, cranking up big time. Temps are not going crazy, dude. 85, 55 at full tilt. Alright, what I really should be doing, I'm gonna fuck around and switch up the music, step 1. What are we gonna run? What do I play? I think I gotta run this again, dude. I can't help it. Alright, so what I have to do is get all of them up to full tilt. Get all of them up to full utilization and see if it can handle it. 78 at full fucking throttle. Yes. Yes, dude. It works. Cooler powered 95% too. Still has some headroom. the other cooler's at 4%. Bro, we're chilling. The thing is loud though. The thing is loud. No getting around that. Wow, is one of them maxing all the way out, and then the other two are at almost maxed. Okay. So let's make 2 more Docker containers. Zero, 1, 2, 3, and 3. That doesn't make sense. There should be 2. 0. What? 0, 2, 3, 4. Oh, so this has got to be 22, 23, 24, 25, 25. All right. So we gotta do develop 3 here. Oh. Oh, no, 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 no. So there that goes. So let's do another. Screen, another. Okay, so we'll do screen. Copy. Screen, bang, develop 4. All right. All right, off to the races. All right. We just kind of have to wait for these two containers to come up. That's cool. Chow, what's going on? Who's in here, bro? Alright, bro. I think we're going to get good numbers here because the other card is the cold side card. So this is also kind of a test for the power supply. You know what I'm saying? Alright. I think it's going to be fine. Yeah, 79. Alright, he's rocking. He's rocking. Both downloading OpenCV. Interesting. Alright, so let's figure out if we can figure this thing out. It is 27 and 26. All right. Is it the Wi-Fi or is it the TTY lag? This is going to be kind of weird to demo. What if I get rid of that buffer thing? Meh. Alright, that totally fried it. I gotta unplug it again. Come on. Damn, heated up too much. Damn. I got too cute. Damn. 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 Fuck. Fuck. Shit. Alright. I gotta reboot this whole container. That's annoying. It's okay. I got a methodology though now. Let's figure out what the hell's going on. With the MicroPython REPL being out of order. Alright, so what just happened was I had to unplug the cooler, and while the cooler was unplugged, the GPUs got too hot and crashed, so I had to reboot the container that they're associated with. Annoying.
judged by people that don't care about me either way. Done with pleasing people who ain't aware. When I feel that way, I just need to breathe for a second. Need to pray, try and make sense of what I made. That the money, every sentence, you can touch them, but put a bunch together, make a record. I'd say I stayed neglected in the game, but I stayed invested. At least I maintain my message. And when I change and I realize the pain I caused, confessed it. All my flaws is on my set list. Every bar was direct with. All the travel days where I miss the city, sitting on my saddle, on the Mississippi, on my trustworthy steed. Out in Europe smoking some untrustworthy weed. The only way to stay high, how I prefer to be. On the bus every day, you wake a new way to say hi, different currency. It's too early for all the urgency.
Alright, so I gotta get this VM back up that has all the GPUs. I don't know if it's gonna want to come back up though, because yeah. Alright, I gotta reboot the whole thing again. Sheesh! That's alright. We got time. That guy, music is gonna shut off because the container's going down. Ugh. It's just a black screen while the GPU comes back up. It's funny. Yeah, I'm gonna have to do like a super hard reset. Let me check. Yep. Goodbye. Alright, it's coming back up. The machine's coming back up. I'm gonna switch to standard mode real quick. Alright, damn. Studio's back online. Haven't checked the GPUs yet. That would be awkward. Alright, we got them all. We got them all. Alright, so what we want to do is where is the Docker Compose file? Oh. That doesn't look right. Yeah, it does. Alright, so... Oh, 0122. That's wrong. I'm glad I checked. We gotta fix that. Alright, so what I'm doing now is trying to load all 4 logical GPUs down at 100% to see how the cooler performs. Which is kind of being annoying because I don't really have what I'm doing. I'm like spinning up a container per GPU because that's the quickest way for me to do this test, but it's probably not the quickest way to actually like, yeah, 0, 1, 2, 3. All right, so now we want to do deployment, upload to development. All right, so nice. So now we want to do we want to do screen DM two, 3, 4, and then screen list, screen R 3532. Oh shoot. Of course. 9. It's funny. 26 3526. 35. I do 2, 3. Okay, so now they're all rocking. Try that 3.5, see where that one's at. Yep. Nice, okay. So that's doing its thing. So, okay, so let's do history, grep, NVIDIA. So we want to do, so what if I do this without the index thing? Let's do all of them. Nice. So I can do, change all the power levels to 175. Yeah. And then I can do, is there a way to do like performance mode? Okay, so nice. So does that come in? Watch and okay, so they're all 175 watt mode. Sick, sick. Okay, so that's still downloading. All right, so let's figure out why this is not working. MicroPython. Let me get my research tab open. MicroPython REPL out of order. MicroPython forum. Let me pull this up. Sorry. Yo, 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 yo. Hey, what's designing a GPU? Yo, Dr. Doll. What's goody, what's goody, what's goody? Welcome to the chat. Alright, so what we're doing, let me show you. So, we are designing a GPU cooler. So, a fan for a graphics card. So, this is the final design. This is two of them side by side. Oops. This is two of them side by side, and you can see that I manufactured them and installed them, and so now we're doing thermal performance testing. So that's them right there on the left side of the screen. So this is a live vid. So this is the, yeah. So it's the idea was, so the graphics cards are NVIDIA Tesla K80s, which are for scientific compute. So I'm using them to train neural networks. And the problem, like, they don't come with coolers, they don't come with fans, because they're meant to be installed in like forced air, like air conditioned environments. So not like inside of an apartment like me. So the idea was I wanted to have enough air power to run them all at like max power consumption without any thermal throttling. So that's what I'm trying to do now is load the cards down to test their performance. Yeah, what's up with you, bro? Dr. Doll, yeah, thanks for stopping in. Thank you for stopping in. doll. Yeah, so I just accidentally unplugged the fans while they were running. So I have to like rebuild my stress test environment, which is kind of annoying and is taking a little bit of time, but it's okay, we're hanging out. Yeah, let me walk back through the cab. That file that I had open. So these are the different iterations that I've done. So this is the final one all the way on the right, but there's this one, and these are both, yeah, cloud computing for my WebGL or 3D rendering. I thought I had them out. It's actually so cool. Let me show you this. These graphics cards in your head, right? So you think scientific. Let me do research mode. So you think in your head of so these cards have 24 gigabytes of VRAM each, right? My RTX 2070 has six gigabytes of VRAM. They're really capable cards. You can do para-virtualization, like you can pass them in through like EXI or ESXi or QEMU, or like, so these are like really capable pieces of hardware, and it's NVIDIA, right? But they're actually super cheap. So if you go on eBay, look how they are $250. It's like, how much would a cloud compute budget run out of $250? You know what I mean? Like my stuff for like training AI, it's like takes like a month, which you like very quickly burn up like thousands of dollars doing this. These things are cheap because you can't mine Bitcoin on them and you can't play video games on them. So they're like the one graphics card that is basically useless for like having fun or making a ton of money through cryptocurrency. But it's so funny because these things new. The MSRP price new. Yeah, I'm messing up the punchline. Yeah, here we go. November 17th, 2014. Tesla K80. Launch price $5,000. So $5,000 down to $250. So it's like, okay, there's still value in it. Like they still have a ton of VRAM, but it's like like a huge cost reduction from when it originally cost. I don't know. They're great. I mean, I've been training AI with them for like almost a year and haven't had any problems with them in that regard. Just cooling them has been kind of a challenge. Yeah. And the earlier versions of the Cooler, like I said, were pretty naive, but they worked. And the one thing they didn't work for was having more than one in the case at once. So you can see, let me pull it up. So this is, so that curved design, this is it installed in the case. You can see here, it couldn't fit a second, you couldn't fit two in there. So once I decided I wanted to have two of these going at the same time, I was like, okay, time to redesign this thing, and so that's what I've been doing.
Good credit scores
Whoa, add.
High scores can also save you money. You can raise your credit score
Let me do this
for free, only with Experian Boost. Download the Experian app now. Results may
delete. Let me do this and then do music over here. Yeah, it's been good. What kind of stuff do you like render? Is it like art stuff, or do you do more? You said WebGL. WebGL. What are you doing with WebGL? That's really cool. Alright, this is deciding not to work. Alright, so I'm making a short film in Blender, and with web, I design web experiences. Oh, very cool. WebGL is so cool. Haven't really had a reason to work with it outside of just like playing around with the console. Same with Blender. I know Blender has a really good Python interface. I've heard really good things about that, actually. I don't know if you saw, I use SolidWorks mostly for doing the 3D design stuff. Okay, so this is almost done. So it's called StyleGAN. So you can, it's something like, have you heard of, let me switch over to it. This person does not exist. Have you heard of this website? So these are outputs of an AI. So you can, it's a process called StyleGAN, and yeah, fake people. So I'm working with an artist who wanted to make video versions of these, basically. So it's a similar process, but you have to generate like 60 frames a second. Like, you have to generate many of these images and training models. So the client wanted instead of like pictures of many people, like just a lot of pictures of like the performer. So it's like a music video that's like AI generated, and because you have you can like really go crazy with the video. Like, you can make the video react to music in a certain way, and yeah, so it's that kind of stuff. Yeah. That's the project. I should have made a like a primer for the whole thing. Yeah. It's so cool. It's very fun. It's been a very interesting project. A lot more, the hardware element of it, like working on the cooler and building out a computer to, like building out a server to be able to hold all the information. Because it's like, okay, we're talking about, so the training set of photographs of the performer was like 60,000 pictures. Like 60,000, like it was like a lot of images. And it's like, okay, how do we move those around? Loading it all into memory. Like, the server ended up having like 128 gigs of RAM to be able to like do all these complex numerical operations. And there's all this stuff that like, even though it's like a very software, like, you know, thematically it seems like it's a, what? No sockets. Oh man, why is this not working? Oh, it's probably because it's up. Okay, thank God. Jesus. Okay, so it's time to load this thing down. Alright, so alright, so what we're gonna do is we're gonna run break ends back to coding. Hey, yo, thank you, doctor. Oh, thank you for the follow, dude. Thank you. Yeah, glad to find you on Twitch. Thank you. Yeah, have a good rest of your night coding. You know where I'll be, brother. Enjoy, enjoy. Peace, peace, peace. Alright, let's get to actually loading this thing down. Alright, so stress test 1. So I'm just going to take this. Okay, I'm not in the screen right now. So I actually want to exit. GPU at localhost, port 2222. Alright, so let's three. Oh, no. I want to do stress test 2. And then I want to do screen again. Again. 2224. Yes. Alright. Nope. Did it again. Test 3. I hear the card heating up. And then one more. 5. Yes. Test 4. Okay, so whoa. Didn't activate Python. Oh, you can I can hear it heating up. Okay. So watch 0. What was it? Color differences and interval. Watch and 0.5 NVIDIA SMI. Okay. Away we go. Away we go. All right. All right, they're heating up. All right, so I'm gonna let this rock for a sec. And I'm going to try to figure out what's going on with the MicroPython being out of order. So, network camera, Firefox, MicroPython forum. Search. Hmm. MicroPython forum REPL scrambled. Alright, well, one thing we could try is SSHing in from, if I do SSH pi at devpi.local. Huh. Oh man. Wow, so that is really heating up. Okay, so oh, working no problem. Oh, working a little problem. Alright, so maybe if I just increase how often that timer loop runs, maybe it's just loaded down too much. The timers are taking up too much CPU. Default cooler, let's do ×3 every 15 seconds. Nope. Right, okay, so that is totally working. Alright, I'm gonna temperature probe it real quick. gonna put the lid on, see what happens. Alright. So the lid's on. Why are those other two doing nothing? Okay, yeah they are. Okay, so I think we're good, dude. It's hauling ass. 77C, man. Okay. So 27 is the one I want to invoke in the video. Okay. Alright, so I'm going to take a quick break and then let's record something.
Want a lawn that looks like
All right, so alright, so I think what I'm gonna do is terminate the recording. Nice. Okay, so stop the recording. So the idea is I'm gonna give an overview. We're done. This thing works, which is amazing. So what I'm gonna do is just give an overview of the project. For kind of a recording thing. So I'm gonna do that now. All right. So today what I have is a GPU cooler for NVIDIA Tesla graphics cards that I've been designing in a couple of iterations over the last, 6 months, but then recently did a total redesign, and that's kind of what I'm presenting now. So this is the cooler in all its glory. You can see there's a Raspberry Pi Pico running MicroPython. There's a bunch of MOSFETs driving 3 fans. Here's another shot from the back. So the reason I had to do this redesign was because in the situation that it's going to be installed in, there's now 2 graphics cards here. In the initial version, there's only 1. Here's another quick photo of the design. You can see the controller kind of sits on the side of the manifold there, and then the fans are on the back. So here are the 2 cards installed side by side. Here's another shot of that. So there's 6 of these 28 millimeter fans, or 40 millimeter fans, sorry, 40 by 40 by 28. You can kind of see it here. You can see it better in another picture. So the way that I'm doing temperature feedback is I have these 2 little thermistor cartridges that are bolted onto the side of the graphics card. So you can't really see it, but these cards, the K80s, are actually 2 graphics cards, 2 logical graphics cards on a single like GPU kind of slot style regular card. I don't really know how to describe it. So there's 2 graphics cards on here, and there's 2, when you plug it into the computer, there's 2 visible to the OS. So the way they're designed, right, it's like this big long thing. So this graphics card is always going to be sucking up the air from this graphics card. So this is kind of what I call the hot side. So the thermistor is placed above the hot side because that's kind of the temperature you actually care about, the temperature that's always going to be higher than the other side. Here's another close shot of the thermistor. So this is getting into some of the earlier mechanical designs. I actually couldn't find a great hole pattern online, so I had to spend some time kind of with the calipers getting that spec'd in. You can see here the first design wasn't meant to sit in a case, in a chassis. It was just sitting on my bench, the motherboard, like that. And I used these blower fans. So these are originally for 3D printer, my Prusa Mark II. I had one of them fail, one of these style fans fail on the printer, and came in a pack of 6, the replacement. So I had 4 replacements sitting around, and that's what I did for this first initial approach. You can see here, actually, I'm powering these directly from my benchtop power supply. Here's the version 2. It was installed in the same configuration, just sitting outside of a case. But this time I had a little bit more control electronics. Not really, right? So this is just a buck boost converter that I was using to vary the voltage presented to the fan, but therefore vary the speed. Again, hacked together really quickly. Not really any thought put into this design. Here's the third version. It's curved, so it's the same model as this one, but I just curved it around at a right angle so it could fit inside this case. Same control electronics as before, etc. Actually, I have another picture of this here. So the problem with this design, this approach in general, right, is these blower fans are very weak. I think it's like the unit of the way you measure how strong these fans are is like cubic foot per minute of air. These fans are, I think, 2 to 5 cubic feet per minute of air they can move. They spin at like 1,000 RPM. These little ones can do 30. One of these can do 30 cubic feet per minute, and they spin at 9,000 RPM. So it's significantly more airflow. So what I would do to get around the thermal problems that the original design would cause would be you can control how much power is presented to the GPU. So I was just throttling down power to get them to operate cooler and not crash all the time. So another goal with this redesign was to be able to operate at actually above their default power rating. So by default, the cards can consume, I think, 125 watts of power TDP. And then you can, in the software, you can tweak it to push that up to 175. So that was the goal of this design, was to have them be able to run at 175. All right, so that's the images. So let's pop into CAD real quick, just to get a better view. So this is the manifold. This is kind of the main part. So there's not a ton to it. The core part is this loft. So if I step the design back, actually we can do, let's do this. So it's this really thin-walled thing, and then this loft. So the way that this loft is defined, the curves are splines that you can just select one by one to add into the feature, but the positioning, which actually, is that file open? I might need to open that file really quick. Oh, I want to hide those in the full thing. The positioning is defined by another assembly. Let me open that really quick. Which was a technique that I used in an earlier approach as well. So having a separate assembly for positioning the component parts, and then having a spline, or a loft rather, to, here we go. Having a loft to like join the two parts. Where is this file? Alright, so, okay, here we go. Interface fitting. So, if we hide the resulting manifold, so this is how the part is kind of drawn. So what I do is then, so these parts are positioned with a bunch of mates, angles, and distances, and then you can actually update these values, these angles and distances here, and then get SolidWorks to spit you out a new model, which is like super useful. It was very, very helpful in prototyping. I don't have to like, every time I wanted to make a change, I don't have to like remodel each of these curves, right? I can just update that assembly, hit the stop sign button, hit the rebuild button, and then get a new part. So outside of the different fans, It's a lot more compact. I also was able to make the walls a lot thinner. These curves provided a lot of strength in the part. The earlier designs were obviously overbuilt, and so these walls are really thin, which ends up like the printing time for this is on the order of hours rather than days like the other ones. So the last thing I want to show for CAD is a comparison of the different versions, just to get an idea, seeing them next to each other. So here's V1 and then V2 and V3. You can see that, yeah, there's a big improvement for each iteration, right? Not to say that these didn't work, but you know, I'm still glad to have finally settled on this design. All right, so that's it for mechanical. Manufacturing wise, I'll pull the photo back up. So I printed the parts on, like I said, my Prusa Mark II in white PLA. I found that even though PLA is usually not the greatest thing to use for temperature sensitive applications, since there's active cooling of the part in a way, it hasn't made a difference at all. Haven't had any sag or melting issues with that at all, because the parts are actively being chilled, right? Even on the earlier designs, same story. PLA is fine for this, turns out. To keep the PCB in place and keep the fans in place, I had threaded inserts, but I don't know if I have a photo of those offhand. Oh yeah, also earlier on to like kind of test things out, I had a one fan configuration of this as well. So I designed this plug that was useful for testing initially. Figuring out which fans to use was kind of tricky. I ended up just picking the most powerful ones, even though they're quieter options, just because I wanted that extra headroom to be able to eke out as much performance as possible. Because I did find that spinning the fans down did significantly decrease the noise. Like right now, you can probably hear it in the background, but I actually have it all running. So these are under full load. It's pretty loud, but idle is actually like very tolerable. All right, so let's switch over to electrical, or try to switch to electrical. All right, so this is the schematic, pretty much as basic as possible. It is 6 NMOS drivers, 1 per fan, all the same parts. It's these FQP30N06L. I think they sold these on SparkFun for a long time. I have a ton of them in stock. I was able to do this whole design without having to buy anything new, which was great, outside of the fans and the graphics cards. And then there's 2 10K 3950 NTC thermistors. So the thermistor package is a little metal can. I actually should zoom in on I have a photo of that. Yeah, it's a little metal thing, a little metal can that has a thermistor in it that's then read by the Pico. Whatever. So, all right, so that the electrical is very simple, which is cool. Oh, there's the, oops, I had that open. So software is where it really kind of gets cool, in my opinion. So let me switch over there. So turn the network camera off for now. So this is the interface for the Teslas. So I have 4 of them. Like I said earlier, 2 logical cards per PCI slot. So 0, 1, 2, 3. So these two are the back card. So there's 2 graphics cards there. So this one corresponds to these 2 cards, and the other one corresponds to the other 2 cards. So this one, you can see the temperatures are a lot higher. It's because it doesn't have this like big area. Like this card has all this surface area to dissipate that extra heat. But this card doesn't have that because it's parked up right against another graphics card. So this one is significantly hotter. The other thing worth noting, right, even within the cards, so this GPU is hotter and this GPU is hotter, and that's that hot side, cold side I was talking about earlier, right? So as the air moves through the system, like this side of the card is always breathing fresh air, and then this side of the card is always breathing warm air. So that's the distinction there. That's why the temperatures are so different across the 4 cards. All right, so let's get into the software a little bit. So I'm using the Raspberry Pi Pico. The cool thing about that is you can use MicroPython, which has been just amazing. I've really enjoyed developing on MicroPython. Lets you do a lot of really cool Python stuff in embedded world. I mean, I've done a ton of Python development professionally, hobbyist level, but obviously Arduino is king for like DIY embedded stuff. I really think the developer experience though with R shell really can plug in anywhere. I'll show you a couple cool things for that in a sec, but kind of getting into the core of the software design. Let me zoom in here. There are 2 timers that we configure in software that map to this callback. So this is a function that what it does is read off the current temperature of the GPU and then set the fans of the associated cooler to like given speeds, right? So the way the speeds are calculated is really cool too. The idea, I wrote an algorithm, it's in this code, you can check it out. Where is it? So it would be this power function. So there's a power function which is exposed by this cooler manager object. The power function takes a float from 0 to 1, 0 being slowest speed possible, 1 being fastest speed possible. So that way you can have different types of fans that implement this power function in a different way, which is cool. So the power function, right, so how do you ask for 100% of 3 fans? You would have all 3 fans turning on all the way, but how would you have 50% of 3 fans, right? You could do it a number of ways. You could have 1 fan full blast and then 1 fan half speed and 1 fan off. You could do 3 fans half speed. A number of different ways you can implement that. So the way that I did it was using a thing called or a number partition. So basically, the idea is to take the different possible fan speeds, right, get a cumulative value. So say you want to drive the whole cooler at 50%. So if you were to drive each individual fan at 50%, you'd get like a value of like 150 total percent that you need across the 3 fans. So then it takes that 150% number and splits it up as many ways as possible. So how many numbers can add to 150? How many combinations of 3 can add to 150? So you could do 10, 40, and 100. You could do 0, 0, or 0, 50, 100. You could do 120, 20, and 10. So it makes all these different combinations and then ranks them by loudness. So the loudness score is you take across the 3 fans, pick the lowest across the 3 values. You pick the lowest average value. or not the lowest average value. You pick, right, okay, so the way it works, sorry, it's not lowest average value. Average wouldn't make sense. So it takes each of the potential fan speeds. So we have this file, fan constants, so different duty cycle ranges. And as an individual fan, as a potential value moves up this rank, it becomes more expensive. So a fan spinning at 4,000 duty cycle, which is like the PWM duty cycle, that is much less expensive than a fan spinning at 60,000. So what it does is take each of the potential combinations, so say, and then score them on how expensive the combination is, and then picks the lowest scored value. It's kind of a roundabout way of encoding the behavior that we want, right? Which is the quietest but most powerful drive speeds for the fans. So this is all going to be on GitHub. So if you want to check this out, you can. There's a couple shortcuts I had to take. It turns out that an integer partitioning thing is a known, like, very hard computer science problem, and it doesn't help that I'm on an embedded processor. So there's a couple shortcuts I had to take there. But yeah, so that's kind of how the software, the fan stuff works. There's a simple function, which I also have, that is basically like a fan curve implementation. This GPU temperature to cooler power. It's hard-coded numbers. If you want to parameterize them, you can, but for my application and just for wanting to be done with this, I just hard-coded them. So I tried PID to do control, but the problem was auto ranging is tough with that. Making the set point, making the system aware of, we really care about two modalities, idling and then under load. The GPU or the cooler has no idea when either of those modalities has been like reached or not. So it was hard to implement that with PID, so I kind of bailed on it. So it's just a regular fan speed controller. So the last thing I want to talk about is the timer functionality. So these timer things are great, these that MicroPython exposes. So these are basically a way to execute an arbitrary callback function on a period of time. So I have it so every 15 seconds it updates the fan speed. So and it can do this in the background, right? So these callbacks get called somewhere. I don't really know how it happens, but that means, so this is a Raspberry Pi, which is connected to the Pico. So I have a picture. So the Pi right here is connected to the Pico. You can see the wire coming in on the top left there. So we can REPL in real time, and we can tweak, we can do development in a REPL in a running system on an embedded processor, which is so much fun. So I have this read thermistor one shot. So it's on pin 26, the thermistor, and it'll get, like, this is the current temperature in Celsius for that thing, for the thermistor. So you can just keep calling this. You can do while true, using a loop, read thermistor, read thermistor, temp 1, shot 26. I want to do sleep here. Whatever. Read. It's not. Okay, so from. Alright, whatever. So my Wi-Fi is messed up because I've got the camera streaming over it, but you get the idea. Like you can do all kinds of stuff in this REPL on the running system, which is so cool. So made debugging and tuning today very easy. So on the requirement of the full load thing, here I have it all running. So these are the 4 cores running. Each of them are oversaturated, overpowered to 175 watts. I have 4 jobs that are consuming all the GPU they can. So these are 4 real loads that I'm doing for my application. And it's going and it's working really well. I got a video feed. So that's what the inside of it all looks like live. Yeah, and that's the project. That's the cooler. Like I said, there's going to be a blog post in the description of this video. Everything will be up on GitHub, of course. And if you couldn't tell, I am currently live on Twitch while I'm recording this video. This is the first time I've worked on a project like this live. I did this entire design live on Twitch, and it's been a really cool experience. More than once, people have had like really awesome feedback points on how to improve the design, etc. People coming in with like papers on what I should consider in like the curves of the cooler, or you know, different like how there was a guy that popped in that used the K80s at work all the time, and they had a bunch of different stories about how they have to cool them, because a lot of people are if you search NVIDIA Tesla K80 cooler, you'll find a lot of people that have published designs. Unfortunately though, I couldn't find any that had like the stackable configuration, which is why I had to roll my own here. But it's been an amazing thing, and if you are interested in that kind of thing, I'll probably be doing a live design like this again. So I did the whole thing, the mechanical, electrical, and software all live, which was really fun. Okay, so 25 minutes. That's very long, but whatever. Cool. Thanks for watching. Like I said, check out the blog post in the description. Peace. So I stopped my recording software. Yeah, I was just wrapping it up. We're done. What a journey it's been. This has been a fun project to do. Want to thank to everybody that have popped in, contributed in any way. Yeah, this has been great. I think soon you should see information about like the project that's going to consume this work. The faces training thing that I've been alluding to for a while. Yeah, cool. Alright, y'all. That's it, dude. Let me take the screenshot, bro. Let me take the screenshot for Twitter. Let me zoom this in even more. Zoom in. Yeah, so you can see that shit. Ooh, yeah. I gotta use my other hand. Okay, I'm gonna draw on this a little bit. I'm gonna draw on this because this is going on the internet. Cool mode, lol. Yes, chat has been real. Okay, dudes, that's it. So fucking wrap. Let me just make sure that that screenshot came out okay. Alright, y'all. That's been great. Alright, have a good night. I'm out. Peace. Wait, let me raid. Let me raid. Yes, I actually remembered this time. Twitch.tv, baby. Stream dashboard. Channel. Uh-oh. Stream manager. Raid channel. Yes, Micah Scott, of course. Start raid. Boom.